Hey everyone, my name is Joseph Briones. Welcome to the course. Today we'll be talking about probability. This is part of the background mathematics unit. This week we'll be talking about background mathematics. Next week we'll be talking about background programming, and then we'll dive into some applications of artificial intelligence following. What is probability? Probability is a subfield or sub-branch of statistics that has to do with uncertainty. Life and nature is uncertain by nature. Data sets that we'll be working with and just in general things that you observe in nature are maybe imperfect or have variation from one trial or one data set to another or one observation to another. And so probability provides us, or probability theory to be specific, provides us a formal foundation for how to manipulate probabilities. What are they connected to in terms of expectation, variance, and also counting, and how can we apply it to solve problems? And so we'll be talking about a little bit of the background probability, what it is, how to set it up, some of the notation, and then diving into an example data set that's fake from somewhere that's local in Arizona. So if you have any comments or questions, feel free to comment on the video or stop me in class, but we'll go ahead and just dive in. What we'll be using today is an example or toy question or problem having to do with coyotes versus wolves. And so in Arizona, there are two species, coyotes and Mexican wolves, that actually look quite similar. The Arizona Department of Game and Fish put up this visual that demarcates difference, but overall, the Mexican wolf or wolves in general are just a little bit bigger, taller. They have a different nose type, but they have very visually similar characteristics. And so oftentimes it may be hard to characterize it. And so what we're going to be answering or using probability to solve is if we observe an animal that's around 2 feet tall, which is around the borderline of where wolves are on the lower end and coyotes are on the upper end, what's more probable? And we'll be using the Arizona Sonora Desert Museum, which is a museum or an outdoor nature preserve and zoo near Tucson, Arizona. That's in Pima County. And this is a fake data set, but we're going to suppose that we're a data scientist for the Arizona Sonora Desert Museum. And we have both coyotes and wolves that coexist in the same environment. And the museum head gives you the following counts of the populations, where coyotes that are short, meaning that it's less than 2 feet tall, there's 24 of them, and there's 6 of them that are tall. Whereas wolves, you can see there's 12 short ones and 18 tall ones. And so what we're going to be asking is if we see an animal that's around 2 feet tall with this, taking this data set into account, what is more likely? Is it a wolf or is it a coyote? And so the museum head tells us that the animal that they observed is around 2.1 to 2.3 feet tall. And we have a data set that gives us either short or tall coyotes or wolves. And so we know that 2.1 to 2.3, that would be classified as a tall animal. And we also observe from the given counts from the museum head that they're the same in terms of total, where there's 30 coyotes and there's 30 wolves, where there's 60 animals total. And so with that taken into account, how can we set this up and solve this using probability? So before diving into solving the problem, it may be at first glance pretty obvious of what the answer is, but maybe not so obvious of how to solve it with statistics or with probability, or if I change the size of the population of the wolves and the coyotes so they're not equal, how you would solve that. And so we'll be going from A to Z about how to set that up so that we have the proper foundation, where if we change any set of variables or if we change the problem that we're solving, we still know how to approach it in the correct way. And so some notation, and this is just a very high level glance of probability and notation. You guys will be taking other statistics courses in your degree programs, and so you should really rely on those for the pedagogical foundation of statistics and probability and what's considered right. But we're just going to be using this as a precursor to give you a feel of what to expect or how to use it and manipulate it. And so some notation that we'll be using is an event, this is a vocab word. An event is a set of possible outcomes. And by possible outcomes, we mean what are the possible observations. And so with this data set, we can tell that the possible observations are that we have a short coyote, a tall coyote, or we have a short wolf or a tall wolf. So there's 4 possible total outcomes. And an event could be a subset of any of those possible outcomes. And so an event could potentially be what is the probability of the event being a wolf or a coyote. And so we'll go through how to set that up formally. And the set of all events is called the sample space. And so maybe a helpful way to visualize this is as a just a little diagram where this would be the sample space. And within the sample space, we've got some coyotes. And then we've also got some, I'll just do wolf instead of wolves. And maybe between them, we've got, this is the short guys, short. Let's make this a little easier to see. That's good enough. So we've got coyotes that are potentially, they're the tall ones at the top. So this is the tall set. This is the tall set. So there's a tall set of coyotes, there's a tall set of wolves, and then there's a short set of both classes of them. And so this would be the sample space. And so an event would be subset of all the possible outcomes or subset of the sample space. Some rules about probability, just to keep in mind, is that the probability is a number between 0 and 1. If it's not between 0 and 1, it's not a probability, or it's potentially set up incorrectly, or maybe you have to interpret it differently if you're given probabilities that are greater than 1. 0 means that the chance of happening is impossible, whereas 1 means that it's certain. And for any 2 events that cannot occur at the same time, which may also be called mutually independent, but we are not going to dive into the details of what that exactly means, since we're just going to be glazing over some of the background math on what probability are. And so for any 2 events that cannot occur at the same time, the probability of one or the other occurring is the sum of their individual probabilities. And so this means that we can use the addition sign, summation. This is a piece of mathematics that we'll be using later in the course too. And then 2 events are called independent if and only if the probabilities of each event happening are equal to the product of the of the probabilities of each event happening. And so what that means is that if there's some sort of dependency between 2 sets of events, where if one event happens, then it's more likely that the next event is going to happen, or less likely, then this is not independent. What independent means is that, and for example, flipping coins is a great example of an independent event, is that one coin flip is not dependent on the next coin flip. And so that kind of captures the key idea of independence. And the last thing is that all the probabilities must sum up to 1. If it doesn't sum up to 1, it's not a probability problem, or it's set up incorrectly, just like rule number 1.